Okay, so welcome to the session, everyone. The first session of our statistics portion of the module, or as some students call it, statistics. Yeah, I know. But it's going to be fine. I promise. Tonight especially is not that hectic. Okay, we're going to go through some descriptive statistics, so what that is and what they tell us. And then we're going to end off with standard deviation and how to do that quick little calculation. Okay. So that is a heads up. There are no surprises. That is what we are doing this evening. I think before we start, I just do want to draw your attention to more resources. You may have seen it, but a couple of days ago, I uploaded a little section in more resources in the lecture slides and resources tab right at the bottom. Yeah, like an intro to statistics, like little thingy. So I would appreciate it if you guys went and had a read of that. And there's a couple of videos there. I also uploaded a link to another Wakelet page that I have kind of been curating from when I started doing the statistics with the honors students at the beginning of the year. So yeah, there's quite a lot of resources there as well, and some really nice videos that explain the concept quite well as well. So if you need to revisit anything. But please, just disclaimer, do bear in mind that I created that for honors students. So there are a fair amount of things on there that you just don't need to know about yet. And so just ignore anything that isn't in your module outline, okay? All that you are doing is, so descriptive statistics, then you will be doing, as part of inferential statistics, you're going to do t-tests, and correlation, and that's it. Okay, so yeah, ignore anything that is not those things on the Wakelet page. But otherwise, it's a nice little exploration of resources for you. Okay, so that is at your disposal. There's also a pack of notes that I made last year when I did this module. Mostly, I mean, I made them because the workbook that is on your student materials was riddled with mistakes last year. And I mean, they have fixed it now. Hopefully there aren't any more, not that I could notice at a glance. We'll see as we work our way through it. So yeah, that's why I made that note pack, and I just made it, you know, funny and colorful and things. So you can go and download that and yeah, print it if you want to, or don't, whatever. But there are notes as well, okay, explaining these concepts that will be useful. And obviously, particularly leading up to your exam, okay. Okay, so with the housekeeping out the way, let's just dive in because it is a bit to get through and I want to make sure we have enough time to practice at the end, okay. Alrighty, so what is descriptive statistics? Okay, so what we should all be aware of at this point is that statistics in general we use in quantitative research to analyze our data. It's a way of us, it's a way that we have to interpret the numbers that we get from people, right? Okay, so in social research, pretty much all of the time you're getting some sort of survey data from participants about something, particularly in psychology. There's a lot of Likert scales that we use. And so we need to organize that data somehow and then make sense of it so that we can test a hypothesis at the end of the day, because that really is the point of quantitative research. It's to formulate that hypothesis, go through the whole process, write the rest of the steps, and then test the hypothesis, do your calculation, and come up with, you know, an answer to that. And so I will run through the steps of hypothesis testing in our next session, okay, because that will relate more to inferential statistics. Descriptive statistics, on the other hand, are very much what the name attributes to them, okay? They are to describe your data. So a lot of the time when you do a survey, even some annoying surveys that you get from VC all the time, or like the bank or whatever, there'll be demographic stuff in the beginning, right? Like you check your height. I mean, okay, height would be a weird one, but if it's a medical one, that kind of like personal descriptive statistics. So like race, home language, you know, if they're university ones, maybe they ask you what faculty you belong to, what modules you're doing, whatever. But that kind of tick box exercise, age, gender, exactly, yeah. So that kind of age, gender, whatever tick box kind of answers in a survey do contribute to what we call descriptive data. Okay, and so we use a couple of different little calculations, but mainly they're just a way for us to make pretty graphs to explain the relationships that are going on in that descriptive data. So if you do a survey of your class, let's just say to, I don't know, get some kind of feeling around stats or something, and you have demographic data, you'll be able to see, for instance, how many, if you want to look at gender differences, a lot of the time that's, a fairly notable difference in data, particularly in psychology, and you'll have that, right? So if you've asked your respondents to tick whether they are male, female, other, etc., and then you'll be able to compare things. Okay, so there are just a couple of things there are 3 types of descriptive statistics. Okay, we're going to go through each of them in turn. So we have distribution. So these are the things that basically tell us how spread out our data is. They tell us, how the data is distributed. Is it distributed evenly or is it skew? Are there lots of outliers, for example? Okay, does it make sense around a mean, basically? Okay, and then we have central tendency. So we're going to actually start off with central tendency. So that is, some of those of you who did core maths would remember the mean, mode, and median of a data set. I'm going to go through that in a second, but basically, and that's what this little picture here is useful for, is that the measures of central tendency tell us how our data relates to the central tendency, which would be the mean of a set of data. Okay, so the middle. How are the data points organized around that midpoint? And that tells us different things. Okay, and then lastly, variability. And this is where standard deviation and variance come in. And essentially, that tells us the spread of the data. So how far apart are the data points from each other, but also how spread out are they in terms of that midpoint of the mean. Okay, so the mean, and we're going to go through that now. Let's click. Oh, I meant to be clicking while we were doing this. Okay, anyway, so distribution. First of all, this is a very important concept, is that, so in statistics, there are 2 types of statistical measures. You get parametric tests and non-parametric tests. Okay, so that you don't have to be super worried about right now. It's more something that you will do at a postgrad level, but it's important to understand that there are different types of tests we can do for when we have normally distributed data. So like when you produce a graph, this is called a histogram, okay, like a bar graph that tells us the distribution, or sometimes this is just a little line graph that would look like that what's called a bell curve. Okay. Normally distributed data follows a bell curve plotted pattern. And basically that is important to tell us because for inferential statistics, you can only use parametric tests for normally distributed data. Data that is not normally distributed for whatever reason, there are other variations of tests that you need to use. Okay, so that's just a concept to be aware of in the background, and that's why one of the reasons why distribution is important. Okay, but also visually, right? So descriptive statistics allows us to visualize our data. So if you think that each bar here could represent a number in a set of data that we've collected. Let's say these are grades from a group of students on a test. And so this is a normally distributed set. It means that most of the results are clustered around the middle, so the average or the mean, correct? And then they taper off at the end in a more or less symmetrical manner. Okay, so it's about that symmetry. And then data that is either skewed to the left or the right would mean that simply if it's skewed to the left, and I know this is confusing because you want to say it's skewed to the right if there's more on the right, but it's to do with the tail end. So if it's skewed to the left, like it goes off to the left more than the right, then this means that the mean and the mode and median fall differently apart from each other. Okay, so I'm going to get there in a second as well. Okay, so just remember this concept of normally distributed data, and then you can have skewed data, or yeah, uniform, which would be weird. It's if your data is all like the same point. That never really happens, but that's the word for that. But yeah, okay, so either normal or skewed. Okay, so our measures of central tendency. Let's talk about this. So the mean, median, and mode. The mean is the average of a data set. And so if you all remember how to calculate that, you simply add up the data points and then you divide them by the number of values that there are in that set. So for this little example up here, there are 7 numbers, right? So there's 2, 2, 3, 5, 5, 7, 11. So you add those all together, you get 35, and then you divide them by 7 equals 5. So it would mean that the average number result in the spread of data is 5. And that kind of makes sense if you're just looking at it, right? Because the middle numbers are 5. Okay, and then next we have the median. So the median is literally the middle number of a data set. It's the middlemost figure. And so you need to always, when you're given a data set at this level, okay, so to do with descriptive statistics, you must always write them in ascending order, so from smallest to biggest. Because if you don't do that and you try and work out the median, you're going to have a hard time because essentially the middle point means nothing if the data is not ordered. Okay, like you can't find the middle of a circle if you can't see the edges, kind of thing, right? So it has to be ordered so that you can find that middle point. So and I mean, you could literally do it manually. I used to do it at school, is literally go and like write it out and then cross off the ones at the end until I arrive at the middle. But yeah, either way, however you work it out, it's the number that appears in the middle. Okay, and then in this case, when you have a data set, not in this case, but I'll show you an example. When you have a data set of odd numbers, it's obviously quite easy to work that out, right? The median, because there will be a middle point. It's like, what is the middle point of a set of 5 numbers? It's the third position, okay? But if you have a data set with an even amount of figures, so let's say there was another number, if there was a 12 here, then there wouldn't be one number in the middle, there would be 2. And so how you work that out is you add them together and divide by 2. And that's how you would arrive at the median if you have a data set that is an even number of figures. Okay, so yeah, you're just finding the mean or the average of the 2 middlemost figures, and that's in that instance. Okay, I'm going to go through this again, so don't worry. Okay, and then the mode. So what the mode means is is the most frequently occurring number. Okay, hold on. I will get to the chat in 1 second. Let me just explain mode, okay, because I have more examples. So in this data set at the bottom here, and remember, you can have more than one mode. If you have more than one number that repeats more than once, then your data set is called multimodal. So there's more than one mode. Okay, so in this instance, we have 2 modes because the numbers 2 and 5 both repeat twice. Okay. Okay, cool. Let me just have a look at the chat quickly. What's going on here? Who's confused? Yes, so in that instance, if there was another number here, you would add 4 and 5 and then divide that by 2. And so the median would be 4.5. Okay. So yeah, it's not, you don't add all of the numbers together and divide by 2, only the 2 numbers in the middle. Is it already too much information? Okay. Let's go through a couple of examples of each again so that we can get a handle on it. Okay. Alrighty. Love the positivity. Keep it coming. Okay, so this in the top right corner here is the formula for the mean. Okay, and so I'm going to now start this explanation of all of the Greek symbols and things that will appear. So if I were you guys, I would start kind of a little glossary for yourselves of symbols and what they stand for. because that will immediately make your lives a lot easier when you are confronted with a formula. If you can just like immediately know that this means the sum of, okay, and it's, trust me, it demystifies this whole thing quite a bit when you understand the symbols, like common knowledge, okay. So this one, when you have an X with a bar on top, literally we call it X bar, that means the mean. Okay, so whenever you are dealing with statistics and you see an X with a line on top, that signifies the mean. Okay. Okay, equals means equals, as it always has and always shall. Okay, and then this is called sigma. It's the big sigma in the Greek alphabet, and it means the sum of, which means the adding together of whatever follows it. Okay, and in this case, X just means the values in the data set. So in general, when you have X, X means a number in the data set. Okay. Similarly with Y, and you will get X and Y when we do correlation next time. Okay. But they literally, and you can write that down, mean they signify a number in your data set, okay, at any given time. So this sum of X means the sum of all of X, so all of the numbers in your data set. Okay, and then divide by N. So N, sometimes it's a little n, it doesn't make a difference, okay? Most of the time it is a little n. That means the number of values in your data set. Okay, so in this example on the board here, n equals 6 because there are 1, 2, 3, 4, 5, 6 numbers, okay? Alrighty, are we all good with that? Does anyone need me to repeat any of the symbol explanations? Or any questions? Cool. Lovely. So N, no, N doesn't mean population. Usually there is, when there's another symbol that means population. It's the lowercase sigma, or what I like to call the onion, because it kind of looks like an onion. We'll get there, don't stress. Okay, so you will be given this formula, I believe, in your exam. I will be checking the formula sheet, okay? You will definitely get any formula you need to do a calculation in the exam. So if you have to do a correlation, you will get that formula, okay? So please rest at ease, that is a fact. You will be given the formula sheet, okay? It's just unreasonable to expect you to memorize those long formulas. It's ridiculous, okay? Alrighty, are we all comfortable with the mean and how to work out the mean? Yes, 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 yes. Okay, excellent. Okay, so the mode, just to go over it again. So the mode is the number in a data set that appears the most, okay? The most frequently, the most amount of times, however you want to think about it, that's what the mode means. And it is entirely possible to have a data set that doesn't have a mode, okay? So, I mean, that could be like a naughty trick question. You know, they could ask you to identify the mode in a data set and the answer would be none. It's a bit rude, but they could ask you to do that because it's a perfectly valid answer, right? Okay, so just do bear in mind the answer can be no mode for this. Okay, and then you can have as many modes as the data set gives you, right? So in this instance, in this little data set here, we've got 1, 1, 2, 3, 5. So there's only one number that's repeated more than once, and that is the number 1. So our mode is 1. Okay, when you've got two modes, also known as bimodal, there will be two figures that appear more than once, the same, like the most, okay? So here, 2 doesn't count as a mode because it only appears twice in the set, right? Whereas 1 and 3 pop up 3 times each. Okay, so yeah, then the modes are 1 and 3. And then very much the same thing at the bottom here. There are 3 modes in this instance because 1, 2, and 3 all appear 3 times. Okay, you're fairly unlikely to get a data set with more than 3 modes in it, because that's leaning towards uniformity, right? If you think about it, if you have too many numbers that occur the same, you're not going to have a very well distributed set of data. Okay. Anyway, we'll get there again. So the median, middlemost number, right? This is what I was talking about. There is a formula for this, obviously, because it exists. But when you have a number of observations or values, when n is odd, you just find the middle position, okay? And the way that you find the middle position, so just remember, like if you have like 400 numbers, you won't in your exam, don't panic. The most you'll have is like 20, I think. But if in the real world doing stats, if you've got like 438 or 37 numbers, you're not like sitting there and counting to the middle figure. A, you'll make a mistake because human eyes can't be trusted. And also, that's tedious. So the way you would do it is you go n plus 1 divided by 2. So like in this instance, and that gives you the position. Yes, we can do an example. I'll bring up a whiteboard in 1 second. Let me figure out how to do that. Okay, we're seeing the whiteboard. Okay, so let's say, let me type then try to draw. So let's say we have some numbers here. I'm just going to put literally random numbers. Oh, no. Getting ahead of myself. I need to put them in order. Okay, so for this example that we've got here, what is n? Someone count these for me. I didn't even count when I was entering them. Oh, excuse my virtual whiteboard skills. Dreadful. So how many numbers are there here? 24. Okay, awkward. I need one more number. Okay, because for the example we're doing, it needs to be an odd number. Okay, so there are now 25. Okay, so n equals 25. All right, so because this is an odd number, we need this little formula. We've got n plus 1 over 2. Okay, so if we had to fill that out, we know what n is, so we can substitute it in here now, right? So we go 25 plus 1 divided by 2. Okay, so everyone, what is 25 plus 1? 26. I will not judge you if you needed a calculator for that. Anxiety is real. Okay, over 2. And what is 26 divided by 2? 13. Okay, so this does not mean that this is the median. 13 is not the median. Obviously, we don't even have 13 on here, but that just happens to be that way. It is the position where you'll find, yes, where you'll find the median. So you go and count 1, 2, 3, 4. Boop. There you have it. 8 is the median of this data set. Okay, so now if this, your brain's just been blown, I hope in a good way. Okay, so let's now take away one of these numbers so that it is even. Let's take out a 9. Okay, so now n is 24. 24, okay? So now we have an even number. It's not so easy to just get to the middle figure and say what that is. So we need to know what the 2 middle numbers are. So in this instance, what are they? Anyone care to offer? If you have 24 numbers, that means half of that would be there's 12 times 2, right? So go to 1, 2, 3, 6, 7, 8, 9, 10, 11, whoop, 12. Okay, so the 12th and the 13th figure, it's 7 and 8. Okay, so what we do is we go okay, so it's n divided by 2 plus 1, but this is the same way of saying how you would write that then would be like, no, it doesn't matter, that's overcomplicating it, it's fine. Okay, so how we would work that out would be 7 plus 8, so you're getting the average, right, divided by 2. $7.5, yes. Okay, lovely, and that would be the median then, not 75. Okay, 7.5 of this data set. Okay, is everyone happy with mean, mode, and median? Wonderful. Okay, let me go back to my slides. Okay, let me go back to my slides. Now we're going to start talking about distribution. Alrighty, so if you have a normally distributed set of data, it is symmetrical. So just think, humans, we like symmetry. Symmetry is normal. That's how you make that association, okay? And what defines a data set as symmetrical is that, and write this down because it will invariably be a good 5 marks in your exam. Like, if it doesn't come up, I'd be surprised, okay? Is that you know that a data set is normally distributed if, yes, it is symmetrical, so it's in a bell curve shape, and the mean, median, and mode are the same value, okay? Or as same as possible. Sometimes it'll be like 6, 6, and 6.1, right? Okay, so those are the rules. It is normally distributed if it is symmetrical in a bell curve shape, and that means that the mean, mode, and median are the same in the middle. Okay. So, and then if it's skewed on either side, it means that if it is, so positive also means skewed to the right, so that's the same, okay? A bell curve shape. Bell curve. It's like an upside down bell, right? Okay, so if we have a positive skew or a skew to the right, so the tail's on the right-hand side, that means that the median and mode are on the left-hand side of the mean. And then the opposite of that is true for a negative skew or a skew to the left. Okay, this is just something to memorize, I guess, at the end of the day. But it is all about where the measures of central tendency, so the mean, median, and mode, where those fall. Yeah. Are we all happy with that? Is everyone, for the most part, at least for now, hunky-dory with normal distribution or symmetrical distribution? Good, love to hear it. Okay, let's get onto the more complicated side of it for this evening. Okay, so measures of variability. This is the measure of the spread, okay? Otherwise, dispersion or the scatter, just the way that the numbers fall apart, okay, on your number line. That is what variability measures. And then so there are 3 measures that tell us this. First of all, and easy to work out, is the range, okay? So, and also, like, just step away from maths. If I ask you, like, what the range of something is, you think, oh, that's from the smallest to the biggest, right? It's the spread, it's the minimum and the maximum value. Like, what's the range of temperature we had this winter, right? Then you would take the smallest number, and then you'd have the biggest number, and that would be the picture you have in your mind. So to work out the value of the range, you take the maximum number, so the highest number, and you minus the minimum value, so then the smallest number. Okay, let's pop very quickly back to the whiteboard just to demonstrate this. So in this data set that we have, okay. So the highest number we have here is 9. Okay, so the range would be 9 minus, and the lowest number we have is 1. So it would be 8. Okay. Alrighty, so then, now getting on to the more complicated calculations of this. Sorry, need to make my slides appear again. I wish it did it automatically. So what is this for? Okay, so the range tells you what, basically it tells you what the minimum and the maximum value is. So you can tell how spread apart the answers to whatever you were searching for are, right? So if I wanted to look, let's say I'm looking at the grade center for assignment 1. Okay, assignment 1, everyone did very well, so it's actually not a good example. But anyway, in any average set of data, especially when it comes to grades, you're going to have a low-ish minimum one, so there'll be some fails, and then you will always have a high value, like someone will do very well and get 80 something or whatever. Okay, so that's the range. It will give you that spread. Okay, I'm sorry, I'm just sharing the slides again. It doesn't do it automatically. Yeah. I do recommend using the workbook because there's some examples in there. So it's on the student resources, student materials. It's there where like the assignments are, should be there. I will try and I think they used to have it as a PDF, but if they've converted it to a Word, I'll find it and then I will do the converty thing and upload it onto Learn. Okay. Anyway, okay, let's stop beating around the bush. We need to speak about the standard deviation. Okay, so, and also just to remember this is that these two are extraordinarily related to each other, the standard deviation and the variance. And you'll see this when we look at the formula in a second, okay? The standard deviation is the square root of the variance. Okay, so just something to remember. That's what that means, okay? But what the standard deviation does, and this is what you must remember, is that it gives you the average distance between each data point from the mean in the middle. So from the average, okay? And now this is in a normally distributed set of data. Okay, in a normally distributed set of data, the standard deviation shows on each side of the mean will go off symmetrically, okay. And then the variance measures, just as a definition, the average squared differences between each data point and the mean. Okay, so that tells you basically the distance of each data point averagely from the mean. Okay, let's try and explain this. Oh, sorry. Ooh. Okay, so this is a very short video. I think it's like 3 minutes. If it loads, my computer has not been doing the things today. That explains standard deviation. Okay, it's not loading. It's fine. You can watch that in your own time. The slides will be there. It's just basically explaining what I've been explaining the whole time. Okay. I'm trying to find this picture that I know exists. There we go. Okay, so this is basically what you're trying to achieve with standard deviation. So what standard deviation tells you is the value of these little sections. Okay, so if you have the mean in the middle here, and remember this is a distribution graph. So this isn't necessarily each data point that is plotted here. It's showing you the average distance away from the mean that whatever percentage of your data falls into, okay? And these numbers will always be the same. So in every normally distributed set of data, 68%-ish will fall within one standard deviation of the mean. So one column away from that middle point. Okay, so 68% of the data. So let's say we are trying to measure the average height of women in South Africa. I don't know, random example. Okay, so if that is a normally distributed set, it should be, then we know that if we can figure out the mean, so the average height, I mean, what is an average height woman, guys? I don't know, 5 feet? 5 something? Maybe? Whatever, let's just say it's 5 foot, right? 5.5, excellent. Okay, so 5 feet, 5 inches is apparently the mean height of women in South Africa. We would know that 68% of all of the other women fall within one standard deviation from the mean. Okay, and then we work out the standard deviation to get that value. So it would give us, let's pretend we worked it out and we got a standard deviation of 2. So that would mean that 68% of women in South Africa have heights within 2 feet of the average, which we've said was 5-ish, 5.5. Okay. This is something that takes time to sink in and repetition, which is also why I throw a lot of videos at you, because it's a lot of examples. So don't worry if it's just not sinking in right now, or what will happen is it'll sink in right now in absolute clarity, and then as we end the Collab, you forget everything. That always happens, but it's okay, okay? Basically, that is what standard deviation is. It's telling us how that average drop-off works. Yeah, okay. And then, yeah, similarly, 95% of the rest of the population will fall within 2 standard deviations. And that makes sense, right? Like if you had someone that was 2 feet shorter than 5'5", that would be wild. So obviously that is a small percentage of the population, right? Okay. Yeah. So we're just making up numbers. Don't take this as fact. Okay. And then, yeah, so then 99% of data that is normally distributed falls within 3 standard deviations away from the mean, okay, at the extremes. Okay, it's okay, don't worry, everything will be fine. Okay, so what we're going to do, that clicked in the wrong direction, sorry. Okay. Yes, let's take a breather for like 1 minute and just center ourselves before we have to do a little bit of maths. So yeah, any questions? Anyone? Was there anything that is particularly confusing? That's just okay. Fine, it's fine. Little people, stop it. Okay. All right, it'll be okay. Okay, let me now show you, and this is a step-by-step process that you will go through to calculate the standard deviation. When you are asked to, you will very likely be asked to calculate the standard deviation in your exam. Okay, and so without panicking, you will be given both of these formulae, although can anyone spot the difference? There's only one difference. Remember, it goes back to the standard deviation, or S, is the square root of the variance. Okay, so literally that's the difference. It's just the square root is the difference. Okay, so that means that once you worked out the standard deviation, you've kind of actually also worked out the variance, because it's that step before you square root your final answer. Okay, yeah, the squared there, right? Excellent. All right. Okay, so we're going to do this example, but I'm going to stop, just go exit presentation mode so that I can actually type the numbers in here. And it's just easier than me drawing this whole thing on the whiteboard. Just give a second for my computer to register that. There we go. Okay, so, all right, the first thing you're going to do is not panic. That's step one. Step two would be to see the things that you need to work out from the formula that you're given. Okay, so we're looking, so I realize my cursor is not showing now because I'm not in presentation mode, but if we're looking at the one on the top right, okay, that's what we're dealing with. S equals the root of sigma of x minus the mean squared. Okay, so that's the sum of those things, which we're going to work out over n minus 1. Okay, that's the formula for standard deviation. You will be getting it. Okay, so so we'd basically draw this table so that we can work this out manually. And the first thing you need to work out is the mean of the data set. Okay, so what you can see is I literally cropped, and there are little chunks of this that we need, and that is worked out in our table. You actually don't even need to do this middle column. That was left in there from correlation. Sorry. Okay, anyway. Let's venture forth. What is the mean of this data set? So what I did was I ordered it ascendingly, so from smallest to biggest in our table. Okay. So you will reproduce a table like this when you are asked to calculate this. So if you have a piece of paper on you, please do this as we go along, because I know that like 99% of you have fallen asleep. It's okay, but hopefully we get some engagement. Okay. All right, so everyone whip out your calculator. Draw this table very roughly so that you can go as we go along. Okay, so let's together work out the mean first of all. Someone tell me the mean. Yeah, so in the exam you would, if asked to work out the standard deviation, you would have to draw your table to work it out. Okay, Landy's given us 15.83. Does anyone concur? Always check. Okay, so remember we're adding the numbers all together and then dividing by 6. Okay, I need one other person to calculate. $15.83. Lovely. Okay. Cool. And we always get this question at this stage. Yes, 2 decimal places. It's always safest to stick with 2 decimal places. Okay. So 15.83. And then, I mean, yes, you can write that in each of the blocks. It's not super necessary, but obviously it stays the same for each data point. Okay. Let me just put that there. Okay. So we're skipping this one. Just pretend this doesn't exist. This is for correlation. We don't need this. Okay. Okay. Now what we need to do is this little bit in the brackets first. So we have x minus the mean, so x bar. So that means for each point, we're going to do this little calculation. So we're going to take the data points. The first one is 10 minus 15.83. And then that will be this value in this column. Okay, so let's work this out, guys. Let's go. What are these values? And yes, there will be some negative numbers here. Okay. Yes. Okay, minus 5.83. What is 11 minus 15.83? Yep. Okay, the next one. So that's 12. Okay, correct. What is 14 minus 15.83? Yes, minus 1.83. Fabulous. And now we enter the positive realm. What is 22 minus 15.83? 6.17. Yes. Okay, and the last one, someone. 10.17. Fabulous. Guys, look at all the maths we're doing. Everything's fine. Okay, so now what we're going to do, we need to get rid of these negative numbers. And how we do that in maths is you square it. So because when you, well, we're squaring it for other reasons, but we're squaring it, when you square a negative number, it becomes a positive number. Okay, that's a mathematical law because n minus times a minus equals a plus. Okay, so just always remember when you get to this last step, there shouldn't be any negative numbers here. There will be the positive version, okay, of that. Okay, so what we're going to do now is we're going to take this column and we're going to square these numbers. Okay, so anyone who might have forgotten, what you do essentially when you're squaring a number is you're timesing it by itself. So if you don't have a scientific calculator on you, you can actually do that with a regular calculator, right? You'd go 5.83 times 5.83, etc. Okay, so let's work this out. What is 5.83 squared? 33.98, great. Oh, it's actually 0.99. So remember when you must round up because it's 33.9889. Okay. What is 4.83 squared? Okay, it's 23.33 because of the rounding, remember? So it's 23.328. And because that 8 is higher than 5, that 2 becomes a 3. Okay. So it doesn't seem like a big deal, but if you've got if all of your second place decimals are the incorrect value, by the time you get to the end, you can be off by like a point. And I mean, technically you get it wrong, which would be an unfortunate loss of like 2 marks. Okay. All right. So what is 3.83 squared? 14.67. Correct. Okay. The next one would be 1.83 squared. 3.35. Correct. Lovely. Okay, nearly there. 6.17. Correct. 38.07. And then last one, 10.17. 103.43. You're on top of it, guys. You're nailing this. Look at this. Sorry for that noise in the background. My dog is trying to break in. Okay. Now, excellent. Look at us filling in our table. So what we now need, so what is remaining in this formula is the sum, right? So we've already worked out this whole bit here. This, you can't see my mouse. It's so irritating. Anyway, on the top right-hand side, we've already worked out this whole bit. I can draw. Here. Here, we've worked out this, okay, for each value. So now what we need to do is work out the sum of that. So we can simply plug it all into this formula, okay? So we need to add all of these points together. Will everyone please do so that we can check if we are correct. Okay, so we're going to add 33.99 plus 23.33, etc. Okay, all of these 6 numbers together. Okay, remember, keep it to the 2 decimal places. Okay, I get 216.84. Seems to be the majority. Excellent. Let's put that in here. 216.84. Okay, so now what we've done, and we're going to hop over to the no rounding. You always, whenever you do this, you just keep the two decimal places. Okay, as much accuracy as possible. Excellent. So what we've done is we now have this whole top bit, right? We've got the sum of x minus mean squared, and so that whole thing is this. We've worked it out, and that's the purpose of the table. So congratulations. And then what we can do is we know what n is. N is 6. Okay, remember there's 6 values, and yeah, minus 1. So now what we're going to do is I'm going to open a whiteboard, and we're going to plug in these values so that we can get our value for s. Okay, and so this now is usually where errors come in. It's just the skill of manipulating a formula. Okay, so this is why practice is important. Let me just clear this. Right. Okay, so we have our formula is s equals root of just reproducing it here badly, but just so that you guys can see it because the slide has gone away, and minus 1. Sure. Okay. So we have worked this whole bit out, so we can just sub that in. Don't forget the square root, guys, because you're going to carry that through all the way until the end. Okay, we go step by step. So we're going to sub in our number. What we got was 216.84. Okay, over, we know what n is. N is 6. Don't skip any steps. Trust me, because you get method marks, and I'll show you how it would be broken down now. Okay, cool. So let's go step by step. What is, okay, well, we know what, I'm not going to rewrite it because we know what 6 minus 1 is. It's 5. Okay, so what is 216.84 divided by 5? Yes, 43.37. Absolutely, and the last step is, nope, you don't ever round up, okay? Oh, I mean, you round up to get to the 2 decimal points, but you don't make it a whole number. Yes, you will be allowed calculators in the exam, absolutely. Okay, so last step is to square root this now. So what is the square root of 43.37? 6.59, the rounding. Ta-da! That's our standard deviation. Okay, it all comes down to rounding. Don't worry, it all comes down to practice. Okay, so when you're rounding a number, let's say we've got 6.5889, whatever. Okay, so when rounding, you just always remember, so if we're rounding down to 2 decimal places, you look at the most immediate number, and then if that is higher than 5, this number goes up by 1. So in this instance, that's how we got to 6.59. Okay, if it's below 5, it remains the same. Okay, so no, 43.37, the square root of 43.37. So in your calculator, you hit square root button, and then you put in 43.37. Yeah, on the pink calculator, there should be a button that looks like this somewhere. It might be in brackets. Someone made a video once explaining all the buttons on that calculator, actually. We should try and find that. I think it's very useful way back. Okay, cool. So now we have the standard deviation. And that is how you do that. And you also coincidentally have, yeah, the variance. The variance is 43.37. Hey, look at you. Okay. Well, we're learning. We're learning things, and that's the most important thing. So then if we just look at a normal distribution, let me just make a little bit of space here. Here we've got the mean, and then this would be 1 standard deviation, that's 2 standard deviations, etc. Okay. And so now we know that S equals this. So that would mean that whatever the average is, 68% of your population will fall within 6.59 on either side of that mean. That's what that means, essentially. Okay. That's it, guys. We survived. We survived descriptive statistics. Woo! Okay, any questions? Let's hit the questions quickly in our last 3 minutes. Does anyone feel even a tiny bit more confident? I love me. Okay, yes, we will absolutely do more examples. And that's also why the workbook is a good idea, because there are examples in there, and then you can work through them. Okay, but we will be doing examples all the time in the collabs. Yeah, so how I'll do basically is next session I'll recap this calculation, we'll do it, and then we'll work in the example into the next calculation that we do. Okay, so basically with any test you do, you're always working out the standard deviation at some point. So it will always be that kind of first step that we do in our collabs. The percentages above mean, what are they again? Okay, so the 1 standard deviation is 68. I think it was then 95. This one's, yeah, 95%. And then 3 standard deviations is 99%. But yeah, there's a slide, and the slide will be up there for you guys soon. Yeah, no, absolutely. You will have calculators, but remember, you do still have to work it out manually. Work out the standard deviation, and yeah, that's the last thing that I did want to point out, is that if you don't show this whole calculation, and if you get this wrong, you get 0, right? But if you show the whole thing, even just from writing this formula out and subbing in the values, you would get a mark for that, and a mark for that. You would get a mark for getting this value correct. You'd get then 2 marks for getting the final answer correct. Okay. So even if something goes squonky and you hit the wrong button in the calculator to get the final answer, and you get it wrong, you'd still get these 3 marks. So please, 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 please never leave out steps. Don't just do it in one step. Trust me, write it out, get those method marks. Okay. Particularly when you do the other calculations that we'll get to. So a full question like this, if they do, they'll probably maybe a 10 marks. If they make you, because you'll get then marks for filling in the table as well, for doing that manually. Okay, but also please do remember that your whole exam is not stats. There will only be a section at the end that will be statistics based. Okay, so you'll likely only have to do one like calculation in the exam. That's what the brief has said previously. But yeah, don't worry about the exam just yet. I mean, worry about it, sure, because I can't tell you not to. But we will do an NSS session before the exam and go over that, and we'll do a revision and practice and tips and things like that, okay? Yeah, so I don't know if they're going to ask you to work out the standard deviation. They might ask you to work out the Pearson's correlation. They might ask you to do a t-test. It really, yeah, it depends. But you will have to do a calculation of sorts. And the rest will be theory questions. Yeah, yeah, absolutely. Yeah, look, at the end of the day, like, I think the brief for last year said there were 20 marks out of the exam for based on this learning unit, so for stats calculations and stuff. And so, you know, out of a full paper, it's not that much, but obviously it's still, if you're aiming for those distinctions, then yeah, it's worth putting the work in to understand and to be able to nail that section. Because I've actually found it's weird marking this section, like students in general either do very well in the section or they do horrifically in the section. There's no like mid ground somehow. So it's like when you get it, you know, and you will get it. Don't worry, you will get it. It has worked out in the past. Got a very good pass rate for this module. Everything will be fine. Okay, practice makes progress, guys. That is the bottom line for all of this. It's about practice. Okay. Okay. Yeah, absolutely. Chip in the brain technology. Do all this for us would be great. We're not that far away. I mean, AI does it all for you now anyway. For us would be great. We're not that far away. I mean, AI does it all for you now anyway. I have a very strong argument that this is all unnecessary and that it should actually be computer-based and practical and use the software, but we'll see. Yeah. Okay, thanks so much, guys. That is us for this evening. Sorry we went a little bit over time. Yeah, any last minute questions I'll answer, but otherwise I will see you next time. Where and how do we integrate stats into research psych? So you mean like in the practice as a research psychologist or just in general in research? There's a lot of quantitative research that takes place in psych a lot of the time, and also in assessments. So all of those Likert scales, that's where stats comes in. And so it's very important to understand the fundamentals of stats, and more so just how to interpret stats than to work them out yourselves. But it's those things of getting the basic building blocks right, I guess, which is why they make you do this manually now. Okay, cool. Have a great evening, guys. I will see you next time.